morning. And especially I'd like to welcome our European people with the DEC program. We're very happy to have you here today. There will be hourly disruptions as people leave here to go on a fab tour. So please don't think it's a comment on anything Mr. Torvalds or anyone else is saying, nor is anyone being rude. It's just the nature of scheduling everything we could schedule all at once. That said, in 1992, Andrew Tannenbaum, the noted computer scientist, commented on the chances of success for a new freeware version of Unix, which was threatening to compete with his $60 Minix operating system. Mr. Tannenbaum observed, anyone who says you can have a lot of widely dispersed people hack away on a complicated piece of code and avoid total anarchy has never managed a software project. Dr. Tannenbaum also observed that Linus would flunk his OS course. Were he taking it? Well, Dr. Tannenbaum must have been right because Linus is still in school. Of course, there's 1 million users of Linux, and there's a Linux journal, which is a paid subscription. It's not an industry freebie, with over 20,000 circulation. And there's innumerable CD vendors selling copies of this free operating system. There's enormous industry about it. Digital is starting to learn that we can't tell our customers what to do all the time. And indeed, Linux was threatening to happen on Alpha despite our best efforts. But something happened. We failed to get in the way quickly enough. And saying no more than that, ladies and gentlemen, Linus Torvalds.
Okay. Well, as you can see from the condition of the box I'm having my slides in, I've been giving this talk before. And the way the talk goes is entirely up to you, because I just have the slides and the kind of knowledge of Linux, but I don't ever write down my talks. And my slides are meant to be a kind of rough framework for the talk. And I'll be more than happy to change the talk. And that's usually how it happens, depending on what people ask me. So I'd ask you all to be as active as possible here, even during my talk. Also, I have one other thing I always start my talks with, and that's just to say that obviously the kernel bears my name almost, but as already mentioned, there has been a lot of people working on it, not just me. The community of developers counts in the hundreds of people if you count all the different projects, not just the kernel, that are being done actively all the time on Linux. Anyway, this is the content slide, which is hopefully not exactly what I'll be talking about. A short introduction to Linux. I'm kind of assuming that you all know Unix, and probably digital Unix in particular. So I'll try to find the differences between Linux and digital Unix. How many of you have been using Linux? Okay, that's maybe a third of everybody here. How many of you don't even know what Linux really is? Okay, one uncertain hand. Okay, that's good. Then I'll just start talking about the kernel. And this is the rough outline of it all, but I'll be happy to just talk about the alpha for a long while, if that's what you're interested in, and we'll see what happens. Okay, this is my what is Linux slide, and actually this mostly talks about the things that are similar to digital Unix, not the differences. We have a Unix clone, kind of like digital Unix, because digital Unix in parts is a rewrite, not based totally on the original Unix sources, I guess. Linux has no original Unix sources. And that includes the networking code, which almost everybody else has been taking from the BSD-Net2 project. But despite having no real Unix source in it, Linux tries to be a very real Unix anyway, so that the user can't see the difference. It's not a minimal clone, it's a full implementation. Also, we're source compatible. That means POSIX.1. And I was told yesterday that Linux actually passed the POSIX.1 testing. So Linux can be called POSIX.1 for real. We have the papers on it now, even though it's been closed for very long. POSIX.1 doesn't mean very much. Most of you probably know about Windows NT also. Windows NT calls itself POSIX.1 compatible, and nobody wants to use that subsystem because it's so limited. So Linux tries to have all the System 4, System 5, and BSD extensions too. And in fact, Linux looks a lot like digital Unix, if you're used to digital Unix. We've left out a lot of the craft. If you've ever looked at how large digital Unix is, you've probably seen a binary that is between 7 and 15 megabytes in size, right? Linux on the Alpha, giving essentially the same features, is about 1.5 megabytes in size. And actually runs pretty well on an 8 megabyte machine, unless you're running X. You can run GNU Emacs and so on in text mode in 8 megabytes. I don't think digital Unix actually boots. So there are a few differences here. But the similarities are still larger than the differences. Linux on the Alpha is actually binary compatible with digital Unix. I haven't tried a lot of programs because I don't really use a lot of programs. The programs I've tried are essentially the compiler and a few editors and some X programs, and they've all ran fine on Linux. But we have not tested things like Oracle and so on. I'm reasonably optimistic that Oracle works on Linux as is or with very minor tweaks to Linux. All the binary compatible stuff includes the shared libraries and so on. Okay. So, I mean, that's essentially the similarities. The major differences are that Linux is freely available with source code. There are almost no licensing restrictions. You can get Linux from an FTP site, and you can copy Linux to your friends, and you can change Linux to your heart's content because you get the sources, and you don't need to pay anybody anything for this privilege. And that's a large difference to digital Unix. It's also one thing that makes Linux very attractive to especially universities, but also to people with limited budgets. And face it, most people have a limited budget. And it's very attractive to people who really need to have source code, either because they don't trust systems without source code, or because they simply want to change it, want to modify the system for their own needs. They may have special needs that you haven't even thought about, that they want to change the kernel for. That's essentially the largest difference in Linux. And unless you maybe count the way it's developed. Linux is being developed also in the open by people around the world, and there is no central authority, except if you count me as the central repository for kernel changes. But if you buy a CD, for example, which I personally think is the easiest way to get acquainted with Linux, that CD contains material from dozens of different projects around the world, and nobody even tries to keep those projects centralized anywhere. It's the CD-ROM manufacturer who goes out and finds the pieces he wants and makes it into one hopefully coherent distribution. That's another difference. It makes Linux very much more flexible than most systems, because you can essentially take all the pieces and work on the pieces piecemeal instead of having to work on it as one large distribution. You're all sitting there nodding like dead fish. It's very boring for me too if you don't ask anything. Anyway, this is the slide I really love. I have it in all my talks. And it's kind of the where are we going slide. And I'd like to point out the logarithmic scale thing, because as every physicist and hopefully every computer science person knows, a straight line on a logarithmic scale, that's really what you want to see. And essentially this means that you're extrapolating 2 years from now, and we'll have 50 million users. And really, I don't see why Digital is so excited about Windows NT, because if you write out the same line for Windows NT, it goes roughly like this, right? So in 2 more years, maybe Windows NT will have 100,000 installed sites. We'll see. It looks very good for now. The numbers are kind of made up, but they are also kind of realistic. There is no way of knowing how many Linux users there are, but these are reasonable estimates. So I'm personally saying that Linux right now has maybe 500,000 users, and many consider that to be a low estimate. CD-ROM vendors sell multiple tens of thousands of CDs every month. So there is a large user base out there, and it's growing still. Do you have, yeah?
Yeah, there's just some input really. Magazines beginning to put Linux on their other CD-ROMs, which puts out, 1 month you can see 250,000 Linuxes getting to circulation per week.
Right, there are lots of, I'm not even counting the magazine CD-ROM stuff, because there is no way of telling how many of those CDs are actually being used. I consider it much more likely that a person who buys a CD from a CD-ROM vendor will actually use Linux than a person who buys a magazine and happens to get a CD with Linux on it will use it. So I'm not counting those. If you count those, there have been multiple millions of Linux CDs done the last few years. Okay, that's kind of introduction to Linux. So if somebody has any questions, I'll be, yeah.
All the distributed development going on, how do you manage people having so many different variations of all that you can't coalesce patterns into?
Okay, the distributed, yeah. Okay, the question was that with all the distributed development going on, how can we make it, keep it coherent, essentially? The answer to that is that we haven't really even tried, but it has worked out very well despite that. One reason, I think, is that because it's so distributed, all the projects are, I mean, the whole is rather large, and when you buy a Linux CD, you usually don't buy one, you buy 4 CDs in a pack or something like this. But despite the whole system being rather large, the subsystems aren't too large. So it's easier to keep track of them. For example, the kernel is only 300,000 lines, maybe 350. So it's not a huge project. Also, when it comes to the kernel itself, there is a kind of self-censorship among people, because very few people feel comfortable about doing kernel development. How many of you are actually kernel developers or have used Linux and being kernel developers there? Okay. 6 people maybe in this room are doing kernel development. How many of those who aren't doing it for a job would like to? Well, there's okay, 2 of them. And essentially, people know that doing a kernel is so hard that even though the sources are easily available, only the good programmers usually tend to work on it. And well, everybody started laughing because everybody thinks that he's a good programmer, and probably 90% think they are better than average, right? Any case, this self-limiting factor does weed out a lot of people. So it's much easier for me to then weed out the obviously bad patches. I usually get something like maybe 20 or 50 patches a week. And as Linux is most of what I do, I don't have any large problem going through those patches. Yeah.
I think the biggest thing of the
Coordination for the people that aren't familiar is the fact that you basically generate the kernel and put it out. So you are the one who creates the kernel sources.
Yeah. This is true of almost all the different projects inside Linux. There is one central person handling, or one central authority, be it a group of person or just a single one, that handles one piece of software. In the case of the kernel, I'm the person that everything goes through. I make kernels available twice a week on average, except when I'm traveling. And even then I usually do it once a week because I log into my machine from abroad. And there simply is no other version of the kernel. Although the copyright does allow you, anybody of you could take the kernel I put out, make your own changes, and make it available to everybody else. And the fact that nobody has done this is mainly because nobody trusts Joe, random loser, to do a kernel the way they trust me to do the kernel. So it's a matter of trust too, yeah.
When you started talking about, you didn't give us an idea of where you came from, why you did this.
Okay.
I think a lot of people are sort of wondering, why are you wasting your time on this?
That's actually that's part of my non-technical talk, and I don't think I have that even with me. Okay, why Linux exists in 3 minutes. 5 years ago, I bought a brand new PC, a 386 running at 33 megahertz. And wow, was it fast. That's 5 years ago, and that's me who was used to time-sharing machines which weren't quite as fast as that. Wow, did it have a bad operating system? I mean, it was running DOS and you couldn't really get anything else, because Unix 5 years ago, if you wanted to buy it, it cost something like 5,000 US. And besides, Finland didn't used to be the center of the earth. So, so I kind of had difficulties even finding a Unix. Even if I had found it, 5,000 US was way over my limited budget. So I essentially had to buy this small $60, well, actually it's $160 package for that Andrew Tannenbaum had done. It's a kind of Unix called Minix, and it didn't really fill my expectations. So there I'm left with a small Unix kind of thing and no money to buy the real thing, and knowing that I'm the best programmer in the world, as we probably all know, so I just decided I'll write my own. And that's not the whole story, but it's close enough. So that's how Linux came to be. And within half a year, I had something which actually worked, kind of like Unix. And I made it freely available by FTP. And although I like a lot of the design decisions in Linux, the technical design, and I think that Linux in many respects is technically superior to many of the original Unix-based Unixes, the one design decision which was to really make Linux better than anything else was just making it available for free, not any technical issues. And I don't consider myself wasting my time. Lots of people did consider this to be a waste of time, because obviously nobody can rewrite Unix in a year. I think I proved them wrong. So, does that cover the question? Okay, you don't seem to be kernel developers, but I'll talk about the kernel anyway, because that's what I'm doing. And essentially, these, no, it doesn't get any better than that. These 4 points kind of, in a nutshell, tells you what I consider to be very important for Linux. A kernel is not a simple beast, but you want to keep it as simple as possible, because it gets a lot more easier to keep track of and so on. Also, I really wanted Linux to be Unix, and that means source compatibility. That has been very, very important for me all the time. I'm very happy to notice that when I installed Digital Unix, or had it installed for me at an alpha, Digital Unix tends to be the same way. Some other large manufacturers tend to think that they can do things better than anybody else, and then they break all existing programs. I wouldn't like to mention IBM, but I will anyway. Also, performance is very nice to have. That's one reason why I do like the alpha. And Linux does perform very well, even on the alpha. But Linux performs well even on low-end hardware, like a PC to a 386. And you can actually use a cheap PC as a workstation. And if you think that PCs are bad machines, you'll be very surprised at the performance you can get from a $2,000 PC and use that as a workstation, instead of buying a real workstation that costs about 5 or 10 times as much. Also, exactly because we have the shining example of Microsoft to look back on, we want to keep it expandable. and not limit ourselves to 32 bits like Windows NT on the Alpha, or to even stranger limits like file names of 8+3 character. So Linux is mostly designed to have as few limits as possible. And it turned out to be more or less trivial to make the Alpha port of Linux a full 64-bit port. Okay. Again, you aren't kernel developers. One reason why Andrew Tannenbaum said I'd fail his course in OS design was the monolithic version versus microkernel issue. Linux is a traditional monolithic kernel. The whole kernel is just one large program. Well, it's not as large as digital Unix, but it's not a small program anyway. And most of the research community tends to think that modern kernels should be microkernels built up from many small programs that together give all the features you want from a kernel. I tend to disagree, and that's probably why I'm still at school. That's uninteresting. Portability used to be a very bad thing for in Linux. It used to be available only on PCs. Now, only on PCs is still about half the computers out there. But when Mad Dog from Digital approached me 2 years ago, 1.5 years ago, about porting to the Alpha, I was more than happy to try to make Linux more portable. And the Alpha was especially interesting for me due to the huge difference between a 386 and an Alpha chip. Notably, the larger address space and the 64-bit issues in other respects too. The portability issues have been, over the last 1.5 years, cleaned up. And I'm happy to say that the Alpha version of Linux is quite as native as the PC version of Linux. They are built from exactly the same source tree, and the architecture-specific parts of the kernel are smaller than in most, if not all, other operating systems. Plan 9 probably is even better in that respect. But so that's another difference between Linux and digital Unix. Linux actually supports a lot more hardware. And we're working on a Spark port right now, which actually works to the degree that it runs X. I mean, it's not just a play Unix anymore. Once a Unix runs X, it's more Unix than many other so-called Unixes. In addition to the Spark, we have a MIPS port going on, a PowerPC port, which will eventually get there but isn't there yet, and well, to digital people, the ARM port might be interesting, the Acorn RISC machine or whatever it's called. It might be very easy to port that to the strong ARM made by Digital. We'll see.